Okay, and shown here is a keystone flap. This is a type of perforator flap, as its blood supply comes from via the perforators coming from the muscle and fascia beneath. And it is a type of advancement flap, as we're moving it just in one direction. This is particularly useful, I find, on the extremities. So let's say your melanoma is shown here, and you're drawing a radial margin around that, and you're unable to close that primarily, and you elect to do a keystone flap. So what you would then do is you would first excise your melanoma with the appropriate margin, and then make the incision for your keystone flap. Now shown here, I've left a little skin bridge. It is a flap. Since the blood supply comes via the perforators, it can be used as a complete island flap, meaning you can actually incise it circumferentially with no skin bridge. But the reason I like to use the skin bridge is that it, well, first of all, provides a little more blood supply via the subdermal plexus, but mainly because since I use this for mostly melanoma excisions, there's a small chance I may need to go back and clean up a margin. This way I can always know for certain what the orientation of my defect was, so I know what margin to re-excise if one is close or positive. I should also mention that you can take this down to the fascia, which is what I usually do. However, if you need even more mobility of your flap, you can actually incise your muscular fascia and move the fascia with it, and that provides a little bit more distance or mobility of your flap. Okay, next we then make our incision for our flap. And as we do this, what I usually like to do is have a little bit of a flare toward the corners here, because we have to close these two edges together, which is what actually gives us the mobility of our flap. And so when I make this one, again, I just create more of an acute angle by kind of flaring out like that. It just makes it easier to close those two edges together. And the same thing here. And the flap itself, the width of it should be approximately the width should be approximately the same as the diameter of the excision. So as you see here, it's approximately the same. And then same thing here. And then what you would do is when you advance this flap, you just basically want to mobilize it enough so that you can move your flap into place. And the main part of the mobility, the critical part, is here at the edges, because this is where the mobility is going to come from. By this little corner here receding away from this edge here, that allows your flap to gain the mobility it needs to reach the contralateral side. And if you need to complete that skin bridge, as long as you have a way of maintaining orientation, you can do that for additional mobility. And the other thing is you can also incise the fascia itself if needed to get maximum mobility, but I find that I don't usually need to do that. So in this particular case, we should also mention one of the most important things about any flap is to maintain the blood supply. And since this is a perforator flap and the blood supply is coming from the muscle and fascia underneath, you can't undermine the flap itself like you would with, for example, a rotational flap such as a rhomboid flap. But if you do need to undermine, you can undermine with impunity any areas that are adjacent to the flap, such as around here. This sometimes will give you additional mobility. Okay, so now we're prepared to mobilize our flap into place. And again, I want to emphasize that the the width of the flap tends to be comparable to, in this case it's a little bit bigger, but at least around the width of the excision, the primary defect, okay? And when we mobilize it, we'll mobilize point A to point A over here, and then as we do that, the corners will pull away from the corner of the surrounding tissues, and we will suture points B and B together here and C together here, so that the flap will look somewhat like this. Sorry, it kind of contorts the model. But as you can see, when we do that, what happens is the corner pulls away from the surrounding skin, and so it gives us the opportunity to place sutures right here, usually about 1 to 1.5 centimeters away from the true corner, and the same thing over here. And again, that provides the mobility of our flap so that it looks essentially like sort of an ovoid or almost like a quadrangular shape. Okay, so let's say you're about to excise a melanoma with the appropriate radial margin as shown here, and you decide that you're unable to achieve a primary closure and you'd like to go ahead and close it with a flap. In this case, this particular flap is called a rhomboid flap. It's a local flap, and it's a rotational flap, and the blood supply comes via the subdermal plexus. You would begin by removing the melanoma with the appropriate margins, and you can just remove it with the as a circular ovoid structure first with the appropriate margins around the melanoma, or you can just go ahead and draw it out like I've drawn here and excise the rhomboid shape as I usually do, down to the appropriate layer, which typically is the muscular fascia. So that then that tissue is then removed with the melanoma or scar, and that creates your so-called primary defect. Now you need to cover or close that primary defect. In this case, we're going to use the rhomboid flap. What you'll notice here is that I've created the excision, the rhomboid, in a very specific way. It should have essentially 4 sides of equal length, and the angles that you would use are approximately 60 degrees for the acute angles and 120 degrees for the obtuse angles. So after you've completed that excision, then you draw the local flap immediately adjacent to it with the same, essentially the same dimensions and same angles as shown here. You will then undermine this flap, the rhomboid flap, generally at the same level as for the excision, which would be just superficial to the muscular fascia, and then rotate it through and using the acute angle so that it nicely fits into place, and with this corner here being secured to this corner shown here, this tip of the flap shown here laying nicely into place in this within this acute angle there, and then just closing all the opposing edges, and then it creates what I generally refer to as like almost like a little dipper shape of your incision line. Incidentally, the defect that you've created in rotating this flap is called the secondary defect, and the way that ends up being closed is by connecting this point here to that point there. So that secondary defect is closed primarily, essentially. Okay, so now you have your primary defect here, and then where your flap is harvested from, you have your secondary defect, okay? And your flap will then be rotated into place with point A coming together with point A on the flap, point B, with point B, which is the tip of the flap, and then C with C, and that will close your secondary defect primarily. So as we rotate that into place, it looks like this. Okay, and you'll get a little bit of distortion of the tissues, and then that covers the primary defect, and then the secondary defect, which is here, will be closed primarily by point C coming together with point C here. And if there's tension and it's a little bit difficult to close, as being demonstrated here, you can actually undermine the surrounding tissues here on this side where C is here, on either side, and just more easily bring those two into apposition with one another.